And before closing, I would just like to address one very important process in this consideration, and that is the cloud process and how aerosols enter into the cloud process. Aerosols are particulate matter that suspends itself in the atmosphere and acts as almost like a mirror, reflecting sunlight. So the direct effect of having more aerosols, which are mostly emitted by air pollution, would involve the reflection of more sunlight and therefore leading to a net cooling of the Earth's atmosphere, partially compensating for the greenhouse warming. In addition to the direct so-called radiative effects like this, we also have indirect effects involving the interaction of cloud condensation nuclei with cloud formation. And this interacts on many different ways, some of which include the longevity of clouds because of the presence of aerosols. The others include the altitude of the mean cloud as you change the amount of aerosols in the atmosphere. And the third one includes the fact that you have drizzle suppression in a more aerosol concentrated atmosphere, leading to increased liquid water content, which reflect more sunlight. So this is actually one of the biggest unknown and one of the weakest links in our assessment of the net response of the atmosphere to human activities. How much this process actually counteract the direct heating effect is still going to be addressed in the fifth report. And lastly, I come back to a part of the world that I came from, namely Asia and the monsoon and so forth. This is a map of the major monsoon areas of the world. And you can see any place which is bracketed by black bold contours where the monsoon regions are. These monsoon regions are characterized by a distinct warm and a distinct dry and a distinct wet season, and are known to be very highly sensitive to climate change. And this is also turned out to be, in a congregate way, one of the most populated regions in the world. How much the monsoon intensity, how much the onset dates of the monsoon change with the onset of severe global warming would be a factor of great concern with the fifth report. So I hope I've given you a basic summary of what we have known so far and what we're going to do in the next round. And I hope this will be some fruit for further thought and discussion. Thank you.
Thank you, Professor Lau, for your excellent summary of the work of the IPCC and the increasing complexity of the scientific assessments, which are, of course, the most authoritative scientific inquiry that we have ongoing into climate change. I would next like to invite Dr. Lee, Director of the Hong Kong Observatory, to talk about the work that's being done here in Hong Kong on climate science and how that is going to impact the climate here in Hong Kong and in southern China. Dr. Lee.
Morning. Morning, everybody. This is just an update of what's happening or what has already happened in Hong Kong. And our results are in general agreement with what's happening in South China as well. IPCC results, as Professor Lau mentioned, gave us the results of greenhouse gas and various phenomena like thermal expansion of seawater. It's likely to give us rising temperature, rising sea level, as well as variability in precipitation and more extreme events. For Hong Kong, we are, of course, very concerned, and IPCC specifically point out several things, like the weather is going to get warmer. rainfall is going to be more extreme. There will be more dry years as well as wet years, and hurricanes or typhoons are going to become stronger, and the sea level is going to keep rising. Unfortunately, for Hong Kong, most of these are happening. Today, I'll be talking about 3 parameters or 3 elements which is done by us, namely temperature, rainfall, and sea level. Of course, we are studying also other aspects like biodiversity, like spread of disease with local organizations and universities. Temperature, we are enabled by the fact that we have urban stations as well as countryside stations, which allow us to delineate or determine the effects of urbanization. And if you look at this curve here, you have appreciated that over the past 127 years, Hong Kong's temperature has risen by 1.5 degrees. 1.5, half of which is contributed by global warming, and half because of urbanization. And if you look at the curve over the past couple of decades, you notice that temperature rise is getting faster and faster. And we are talking about 0.3 of degrees per decade, according to the latest trend. I'm giving you raw data on all this curve, raw data so that you can appreciate the year-to-year variability of the climate elements. And in this, we give you the cooling degree days, which is related to the amount of energy that we will use to cool the weather to make it more hospitable. And we attempt only a linear fit so that it's less biased as opposed to a curve, fitting a curve or spline. And all these figures tell us that temperature is getting warmer, and we will look at the number of days where we have minimum temperature of 28 or above, which we call warm night in Hong Kong. We see that after the war, soon after the war, we practically didn't have any nights warmer than 28 degrees. But up to now, the latest figures tell us that we are now getting 20 nights of such temperature. So the increased use of energy is going to make it worse, meaning that people are using more energy for air conditioning, and that would churn out more emissions of greenhouse gas into the atmosphere. Another element that we measure is, again, the sea surface temperature. And over the past 30 years, we noticed also another rise, a rise of half a degree. And Professor Rockström told us that this is irreversible because the water has a tremendous capacity for heat. And now that it has warmed up by half a degree, and it's quite alarming for us. So the conclusion that we have on temperature is that it's going to get warmer, and the demand on energy use is going to increase. And the question, of course, is whether we can usefully deploy this excess heat. Next, I'll move on to rainfall. This tells you the hourly rainfall figures, that the maximum hourly rainfall that we had over the past 127 years. And you notice that the rainfall rate has stayed more or less at around 100 millimeters for many, many years, until the last few years, when the record kept broken again and again. And suddenly, in 2008, we get a record rainfall of 145 millimeters in an hour. And that's a big increase, almost 50% increase in the rainfall rate. And if we look at the return period, that tells us that the heavy rain is going to become more frequent. Previously, a return period of 37 years will become 18 years. We also look at the total rainfall contributed by heavy rain, which we call the 95th percentile. And again, you see that Hong Kong's rainfall is increasingly contributed by heavy rain. And this is understandable because as the air gets warmer, it's more difficult to rain. This tells us that the period of dry days is getting longer over the century, and since it's harder to rain, so when it rains, it pours. The IPCC results give us the basis to calculate the rainfall projection for the rest of this century, and we see that rainfall will have an increase of 10% rainfall by end of this century, but there will also a shortfall of 5% in the near term. And you also notice that the projected rainfall is quite variable. That means when we have dry years, there will be competition for fresh water. We rely on South China for 2/3 of fresh water. And if there are drought years, then there will be pressure if we are going to continue to grow and develop in this part of the world. So we expect the dry years to double this century and wet years to increase 5 times. So the conclusion is that if it's harder to rain, and if it rains, it pours. And we expect more calamities like flooding, as well as landslip incidents, in view of the fact that the rainfall is getting more intense and more short duration, more of shorter duration. Last, I'll move on to sea level rise. Hong Kong has noticed a 14 centimeter rise over the past half century, and IPCC projects a 0.6 meter rise by the end of this century. So what it translates is that the latest projection is that the major contribution to sea level rise will still be the thermal expansion of seawater, to be followed by melting of glaciers, such as the Himalayas. Himalayas, in fact, are providing meltwater, source of fresh water to many people. If you consider China, Indochina, Myanmar, India, the rivers all flow into these countries. And we are talking about a population of something like 200 million people being affected by the disappearance of glaciers in the Himalayas. And of course, the great ice caps, Greenland and Antarctic. But these are not going to concern us too much. Right now, I think we are seeing a big contribution from the thermal expansion because of rise in of the sea level temperature. And the picture for the projection, since 2007, there are new results, and the results are more pessimistic as opposed to 0.6 meter. Scientists are expecting more than 0.6 meters. They are pointing to something like 1.4 meter to 2 meter.